So now we start the class. This is the lecture 4. This was the previous lecture. Uh, Electrophilic addition to halogen acid to carbon double bond carbon, stereochemistry, Marconi-Cope addition, anti-Marconi-Cope addition. We have discussed and we have performed some activities. Any question related to previous lectures? कोई सवाल तो नहीं है इसमें? चलें आगे चलते हैं फिर. Lecture 4, we will discuss these topics in this lecture: electrophilic addition to halogens to carbon double bond carbon, their mechanism, stereochemistry, and unsaturation tests. These topics will cover in this lecture. The title of this lecture 4, electrophilic addition of X2 halogens, chlorine, bromine, and iodine to carbon double bond carbon. This is our fourth lecture. Electrophilic addition of halogen to carbon double bond carbon. In the previous reaction, we have discussed electrophilic addition of halogen acid to carbon double bond carbon. Now we are discussing halogen, addition of halogen to carbon double bond carbon. Alkene react with chlorine and bromine in non-nucleophilic solvent to form vicinal dihalides. Chlorine and bromine. So this is the alkene. This is alkene, symmetric alkene react with chlorine, form this vicinal dihalide, means uh, two carbons, the chlorine attached with the two adjacent carbons. So with the two adjacent carbons means vicinal. The chlorine attached with two adjacent carbon, it is this the term is used vicinal. Vicinal dichloride, vicinal dihalide, vicinal dichloride compound. So vicinal dichloride compound is formed 100%. Another example, this is the butene, 1-butene. It is unsymmetric. This is symmetrical alkene. This is unsymmetric alkene. React with chlorine. Temperature below 0 degrees centigrade. And this reaction is performed. In result, vicinal dichloride is formed 97%. The third example, this this alkene, this is the alkene, this is hydrogen and CH3, this is symmetric alkene. This is symmetric alkene, symmetric compound, and this is symmetric compound. It means it is non-chiral, achiral compound. It is not chiral. The compound is not chiral, and the dipole moment is zero. In this compound, this CH2 is not the stereo center or chiral center, so stereo center is not there. In this case, this is cyclohexane react with bromine in presence of carbon tetrachloride. Carbon tetrachloride is not the polar solvent, and temperature below 0 degrees centigrade. We obtain two type of compounds, mixture of two compounds. These compounds are enantiomer to each other. If it is R, it will be S. This is S, it will be R. And this is the trans. The two bromine will be attached with trans fashion. Trans 1,2-dimoromo, cyclohexane. These are the enantiomers. The bromine is added to the alkene with trans fashion. Opposite side to bromine attached with opposite side. So this is the racemic mixture. 50-50% enantiomers are obtained. Yes, this is very interesting. Unsaturation test by bromine. If I hope you have performed in the lab unsaturation test. The one unsaturation test by K-4, by which you can determine the unsaturation or saturation in the compound. You take uh, the compound in the solution of K-4. If the K-4 solution is decolorized, it means the compound is unsaturated. Otherwise, the compound is saturated. So this is another unsaturation test by bromine. You will take the bromine water and the compound is added. The red brown color of bromine is disappeared. It means the compound is unsaturated. Alkene may be present. So this is the unsaturation test of alkene. You can determine the colorless alkene and red brown color of bromine at room temperature in dark uh, bromination. Bisphenol dibromide is obtained, rapid decolorization. This is the another unsaturation test by using bromine, by which you can check the unsaturation of alkene. Alkane do not react with bromine. Alkene, alkane do not react with bromine in absence of light. In absence of light. This perform radical reaction in presence of light. You have already studied about alkane reaction, halogenation of alkane. The alkane react with halogen in presence of light. This is the free radical mechanism. But the alkene react with halogen uh, in dark by polar mechanism. Okay, by polar mechanism. So the alkene do not react with halogen in dark. So and the alkene react with bromine with halogen in dark. So this is you can distinguish saturation and unsaturation by performing this test. Alkene perform ionic reaction in dark. Okay, so this is the application of unsaturation test by bromine. Mechanism of bromine, iodine, chlorine to carbon double bond carbon. This is the ionic or polar mechanism. Ionic mechanism or polar mechanism in which nucleophile and electrophiles are involved. Pi electrons of alkene polarize the bromine molecule. The bromine molecule is not the polar molecule, but when it come to close, bromine come to close to the pi electron of alkene, the pi electron density polarize the bromine molecule by repulsion of electron attack. Due to polarization, bromine is weaker, bromine-bromine bond is weaker and break hydrolytically. Most of the time the bromine bond cleavage homolytically, but here due to pi electron density the bromine-bromine bond is polarized and break heterolytically. Heterolytically means one bromide has partially positive charge and one bromide has partially negative charge. Vicinal dihalide is obtained in the in result and the intermediate bridge intermediate is observed. In the first step, the bridge intermediate is observed. Due to bridge intermediate, the two enantiomers, two-side attack is possible. So now we discuss the mechanism. This is the mechanism. It consists of two steps, step 1 and step 2. Step 1, this pi electron density, when the bromine molecule come too close to the the pi electron density repulsion polarize the bromine molecule. The one bromine which is near to the double bond, it has partially positive charge, and the bromine, another bromine which has partially negative charge. So this now it is polarized and and bond is weaker and hydrolytically cleaved. So this pi bond attack on this pi electron attack on this bromine, and this bromide will be removed as a Br negative. The slow step and rate determining step and reversible step. This, this carbon and this carbon both are sp2 hybridized. In result, uh, this carbon attack on this bromide, and this bromide again stabilize by attaching with this carbon. So this carbon and this carbon, now both carbon are sp3 hybridized. Here two carbon sp2 hybridized. Now after the first step, both carbon sp3 hybridized because every carbon form four covalent bond. So this is the bridge intermediate. Bromide has lone pair, and the lone pair form a bond with this carbon. So this is the bridge intermediate. This is the intermediate. Intermediate is that compound which is the intermediate compound is stable and actually form, and you can observe and isolate stable. So this is the bromonium ion. This is the bromonium ion. This bromonium ion is stable, and this is the bridge intermediate. sp3 hybridized, sp3 hybridized both carbons. And in case of chlorine, chloronium ion. In case of iodine, iodonium ion. And this is the bromidine. Bromidine. In the second step, this bromidine act as a nucleophile, and it perform SN2 mechanism. In the second step, it perform SN2 mechanism. What is the condition of SN2 mechanism? The bromide, and in the SN2 mechanism, nucleophile attack from opposite side attack फ्रॉम द लीविंग ग्रुप. जो लीविंग ग्रुप निकल रहा है उसके अपोजिट साइड से अटैक करता है. तो सिमिलर फैशन हेयर SN2 मैकेनिज्म, द ब्रोमाइड अटैक ऑन द अपोजिट साइड ऑफ दिस ब्रोमीन. ये जो ब्रोमीन है इसके अपोजिट साइड से अटैक होता है. तो देर आर टू ऑप्शंस. Two sides are available for attack. This bromide can attack on this carbon and bromide can attack on this carbon. अगर यहाँ अटैक होगा ब्रोमाइड तो ब्रोमीन यहाँ चला, ये बॉन्ड यहाँ चला जाएगा, ये यहाँ पे ब्रोमाइड लग जाएगा. अपोजिट साइड अटैक, द अपोजिट, दिस इज द एंटी प्रोडक्ट इज ऑब्टेन. एक ब्रोमाइड यहाँ लगा हुआ है, एक ब्रोमाइड यहाँ लगा हुआ है. अगर ये यहाँ अटैक होगा इस जगह पे तो ये ब्रोमाइड यहाँ लग जाएगा, ये ब्रोमाइड यहाँ लगा हुआ है, ये ब्रोमाइड यहाँ लगा हुआ है. So there are two sides are available for attack, this carbon and this carbon. In result, the two compounds will be obtained with two different stereochemistry. Stereoisomers are generated. Two enantiomers are diastereomers. So this is the first step. Bromide attack on this carbon and this carbon. In result, sp3 hybridized sp3 single dibromide is obtained. The stereochemistry. Now we discuss stereochemistry. Stereochemistry of addition of X2 to carbon double bond carbon. Further evidence of backside attack evidence. What is the evidence? Anti-addition. The product is anti. Anti means opposite side. The bromide, two bromine are attached in opposite side, which is the evidence of backside attack or SN2 mechanism. And this is the cyclopentene bromine react in presence of carbon tetrachloride solvent, non-polar solvent. This is the two compounds were obtained. Opposite side, anti-product. This is what they are called, trans or anti-product. Trans means trans 1,2-dibromocyclopentane. So two products are obtained, both are enantiomers to each other. So this is called racemate. And this is the pentene bromide. This is the mechanism. Bromine react with cyclopentene. There are two options. This is the intermediate bromonium ion, and there are two options: A attack on this carbon, and B option attack on this carbon. In result, two enantiomers or racemates are formed. Opposite side. This is the beta, and this is the alpha. Beta means front side, and bromide means back side. Here the bromine is back side, and here the bromide is front side. So opposite anti or trans product is obtained, and two enantiomers are formed. An anti product or trans product and stereochemistry is also there. Another example, this is cyclohexene, six-membered ring. Previous example, five-membered ring. Now the example of six-membered ring, cyclohexene. Bromine react with cyclohexene. There are again two enantiomers are obtained, trans product. The mechanism, this is the actual form. This is cyclohexene. Uh, a double bond in between 1 and 4 position, bromine react. Now this is the 1 and 4 position, 1 and 2 3 4 5, 1 2 3 4 5 6, and this is the 2 position, 1 and 4. So this is a bromonium ion at bromide attack on this carbon and this carbon. So what is the difference between two attack? The one is anti-product, means the diaxial. Now we first discuss this cyclohexane. This is the cyclohexane. You have studied about the stereochemistry of cyclohexane. There are two and conformational analysis. The cyclohexane, this is the chair form, the 3D structure you have discussed in the previous classes. The chair form and board form. These are the two stable conformers of cyclohexane. This is the chair form. These hydrogens, this one and this one, which are circled, they are called axial hydrogen. And these hydrogens, which are not circled, they are equatorial hydrogens. So they are the axial. This is above the plane, below the plane, above the plane, below the plane, above the plane, below the plane. Similarly, they are the equatorial, below the plane, above the plane, below the plane, above the plane, below the plane, above the plane. And this is the another form of chair conformation, this one. And this is the board form of cyclohexane, chair form and board form. There are a number of uh, conformers in between chair form and board form, but they are two stable form. The chair form is more stable than board form. So here we are discussing about chair form. Two axial means this one. This below the plane axial and the adjacent axial above the plane. So in this case, diaxial product, this one and axial product attack from two. If attack on one position, then the equatorial product. This is also a trans anti above the plane and below the plane. Okay, and this is the di-equatorial product, and the diaxial is converted into by reversible process in di-equatorial, and di-equatorial is converted into diaxial products. The di-equatorial product is more stable as compared to diaxial product. It is dominantly formed. So this is a cyclohexene. These are the evidences of anti-additions or trans product formations. So this is the stereochemistry, and there are two different things. One is the anti-addition, trans product is obtained. The second is the stereochemistry is there, the racemic mixture is formed. So this is the idea of addition of halogens to carbon double bond carbon. So yes, any question related to this lecture? Yes, कोई सवाल करना चाहें लेक्चर से मुतालिक। जी, कोई सवाल नहीं है? चलो यहीं स्टॉप करते हैं, ठीक है। ओके जी, अल्लाह हाफिज।
अल्लाह हाफिज़ सर।